Now the different characters or like different properties of soil is, the first one is texture of soil. Okay, texture. So we can feel the texture of soil by touching with our fingers. Okay, and texture means the like softness or this like roughness when to touch. Okay, when we touch it, how do we feel, how you find it? So is the soil smooth and then soft, or is the soil very coarse and rough? Okay, now if you take the example of sandy soil, then sandy soil will be very coarse. Okay, if you touch this sandy soil, then you will find like big particles. In the like previous topic, we have seen that sandy soil have big particles. So since the soil particles are big in sandy soil, well, like it is coarse and then it is rough when we try to find out the texture of the soil. Okay. Otherwise, clay soil. In clay soil, the soil particles are very fine. They are very small. So when we touch this clay soil, we feel that the clay soil is very soft and then very smooth to touch. Okay. So these are the like by this texture we can find out what type of soil is that particular soil is by touching it and then by seeing the coarseness or this like this smoothness of soil. Now among three types of soil, that is sandy soil, clay soil and loamy soil, clay soil will be the smoothest. Means this is like the particles of this clay soil is very small, that is why the smoothest soil will be clay soil. Otherwise, loamy soil. Okay, in loamy soil we have learned that it has got both big and small size particles. Okay, and loamy soil consists of both this equal amount of sand and clay. Okay, so loamy soil is medium, like between this, it lies between this sandy soil and clay soil. When the sandy soil is very coarse and rough, and when clay soil is very smooth and then soft, loamy soil lies in the middle. It is medium. Okay, it's not too rough or not too smooth. Okay, so this is the texture of soil. Now next property of soil is moisture content. Okay, moisture content. Moisture content means it refers to the amount of water it can hold. Okay, so amount of water. Okay, amount of water it holds. Now, in the previous topic, we have seen that sandy soil cannot hold water. Yes or no? So, since sandy soil cannot hold water, sandy soil, the moisture content will be very low. Okay, moisture content will be low in sandy soil. Whereas in clay soil, we have seen that they can hold a lot of water. So, moisture content will be high in clay soil. Okay, so amount of water present in the soil, that is the moisture content. Now the third property of soil is absorption of water. Okay, so the water holding capacity. Okay, how much water can a particular soil hold? Okay, water holding capacity. Now we can find out the water holding capacity of different types of soil. Okay, for example, take like 3 conical flasks. You have this is a conical flask. Let us take 3 conical flasks because we have got 3 types of soil. Okay, and then we will take this funnel also. Funnel. Okay, funnel is like this, somewhat like this. So this is a funnel. Now on this funnel you take a filter paper also. Filter paper, roll this filter paper and then put inside this funnel. Okay. So we have taken 3 these conical flasks, 3 funnels, and then filter papers for each of this setup. Now we will put sandy soil here. Okay. Now we put sandy soil here on top of this funnel. Here you put loamy soil. You put loamy soil here and you put clay soil here. Okay. So clay soil here, you put soil. After that, what you will do? Take 500 ml of water. Okay, we will take 500 ml of water and then we will pour here. In each of these flasks, conical flasks, we will pour water here. Okay, now as you pour the water, you will see that the water will be falling down here and then it will get stored up here. Okay, So let us see what is the how this water falls down here. Okay. Now if we take the sandy soil first, in the sandy soil we have kept sandy soil here, we have put sandy soil here, and then after that on top of this we are going to put water. Okay, so when we put water on the sandy soil, we know that sandy soil cannot hold water. Okay, so sandy soil on top of this water, as we put this water, the water will start dripping here and then water will get filled up. Okay, in loamy soil also, like this loamy soil, we know that they can hold little like some amount of water also and some amount of air also. Okay, so here we have put loamy soil putting here, and then on top of this one also we are going to put water. Okay, when you put water, again, like you will see that drops of water is falling down here. Okay, and likewise even in clay soil also you will put water, 500 ml water. So if you put water, then you can compare between these three. Okay, when you compare between these three, which bottle or which flask do you think will be filled up more? You will see that the conical flask containing the sandy soil will be having more amount of water, because sandy soil, through the sandy soil, this sandy soil cannot hold water. Okay, we are talking about water holding capacity. So we are trying to find out how much water can this sandy soil hold. Okay, so we will find out that sandy soil cannot hold water, and then we will find that all the water from here is going down and then falling inside this conical flask. Okay, and these two also, loamy soil also, they can hold some amount of water. Okay, so some amount of water will be here, so only few will be falling down here. Yes, some person will be held by this soil, and some amount of water will be falling down in this conical flask. Now in the third one, clay soil can hold a lot of water. Okay, so when you pour water, this clay soil will hold all the water, and then only few or only less amount of water will fall down in this conical flask. So from this experiment, we will find out that water holding capacity of clay soil is the highest. Okay, clay soil has the highest water holding capacity, or the absorption of water is highest in case of this clay soil. Okay, so this is also the property of soil, and then we can find out the water holding capacity by this small experiment. Okay, now let us talk about the next property of this soil, that is the percolation rate. Okay, now this percolation rate means the rate at which the water moves. Okay, rate at which the water moves. Water movement, or like travel of water. Okay, so the percolation rate of water. Percolation rate of soil. Okay, so from in the soil, at what speed? Okay, at what speed will the water move through or pass through this soil? Now suppose you take a sandy soil here, and then you you pour water on this sandy soil. Okay, so through the sandy soil, water will travel very fast. They cannot hold water. Just now we have seen that they cannot hold water. Okay, so this is because sandy soil, through the sandy soil, water can travel very fast, or water can pass through very fast, or water can percolate through it very rapidly. Okay, so percolation means movement of water. The rate of the percolation rate means the rate at which the water moves through a soil. Okay, so different types of soil have different percolation rate. Okay, now just now I've given you the example of, now this is a sandy soil, so they have they cannot hold water. Okay, cannot hold water. So water holding capacity is water holding capacity is very low here. Okay, so if the water holding capacity of this very particular soil is low, then water will pass through this one very fast. That means percolation rate will be very high. Okay, if the water holding capacity of a soil is low, then percolation rate of the soil will be high. Since they cannot hold the water, water can pass through them very rapidly. So from here we can know that if the soil has a very low water holding capacity, then they have this type of soil have this very high percolation rate. Okay. Now in other case, clay soil can hold water. They have a very high water holding capacity. So in such type of soil, the percolation rate will be very low. The movement of water will be very slow. Yes, no. Since the soil is going to hold the water, the percolation rate is very low. The movement of water through this soil will be very low. Okay, so this is the meaning of percolation rate. So this is the fourth property of soil, and we have the fifth property of soil. That one we will discuss in the next video. Thank you.